Warm-ups for lesson 3-2. Pause and answer the question. And here is the answer. It looks like the intersection is on the x-axis and this point is on the x-axis. Pause and try to answer the question. And here's the answer. It's going to require two equations. An equation that creates the number of problems, an equation that describes their worth. And in order to use elimination, I'm going to multiply the top by -3, and you can see we solve y is equal to 10. 10 multiple choice questions. Lesson 3-2, solving systems of inequalities by graphing. Objectives: solve systems of inequality by graphing. Determine the coordinates of the vertices of a region formed by the graph of a system of inequalities. Okay, in order to solve a system, we're going to graph each inequality, shading the correct area. We're going to identify the area that is shaded for all the inequalities. This is known as the solution of the system. In this problem, y is greater or equal to 2x minus 4. That's this right here. This is the equation. Notice it has a dotted line because it is greater than. And we want values that are on the top of it. So that's why region 1 and region 3 will be the solutions for this particular one. Now for this one, this is the boundary line. And notice it's solid. And because it says less than or equal, we want regions underneath that are smaller. And this will be region 2 and region 3. Now what they have in common is region 3. So this is what both systems have in common, region 3, and we say that region 3 is the solution. All these points actually satisfy both of those inequalities at the same time. All right, let's go ahead and do a problem. I've already graphed the boundaries. So this particular one is the red one. It's 5. You can see the y-intercept is 5 down to over 1. And what I'm going to do is I'm going to shade by just creating dots here. And so it's shading underneath. Now for the second one, the second boundary, it's at -6, and then the slope is down 1 over 4, down 1 over 4. I'm going to now shade above the boundary, and where the two shadings intersect, that's what we call the solution. So you can see right here, this little party mix right here, that represents the solution. All these points in here satisfy both at the same time. Your turn. Pause and try to figure out the answer. Here's the answer. I went ahead and graphed both boundaries, being very careful to shade underneath for the red one and shading above here for the second one. And I can see this is where they intersect, and this is the solution. Those points represent answers to both of those at the same time. Pause. And here's the answer. One of the things you ought to do for yourself is solve for y so that you can go ahead and graph the boundary line, and then you can shade above it. And over here, I took the 3x to the other side. I multiplied both sides by -1. Remember, multiplying by -1, you change or reverse the inequality, and so then I was going to have a less than or equal, which is going to shade underneath. So right here where the little party mix is, that's where the solution is for both of those equations. Let's take a look at, sometimes the system of inequalities doesn't have a solution. In this case, the solution for this one is above, and the solution for this inequality is below. Notice they don't share anything in common, so we say that the solution is the empty set. In other words, there are no solutions that'll work for both at the same time. Pause. All right, I eliminated C and D because none of these had less than or equal or greater than equal, and these were solid lines, so I eliminated those. So I knew the answer was either A or B. Now over here where we go up 4, 1/2 x plus 4, it says less than or equal, so we got a shade underneath. This one shades above, so I knew it had to be A, so it's this alley between the two parallel lines. Let's go ahead and find the vertices of an enclosed region. Sometimes we have 3 inequalities and it creates a region, and we want to find the corners of those. Now, I have already graphed this portion right here. I've already graphed -1, down 1, over 1, and I shaded above. All right, now what I want to do is I want to shade x less than or equal to 0. The y has to be less than or equal to 0. The y has to be less than or equal to 0. So I'm going to graph y is equal to 0, and then I want y less than or equal to, so I want less than right here. All of these are y's that are less than or equal to. Okay, now I want to go to another line, and I want x to be less than or equal to 0. So I want x's that are negative or 0. So I'm going to go ahead and graph x equal to 0, and I want values that are less than, so right here, less than. Now where all 3 intersect is this triangle area right here, and this triangle, the vertices are the origin, and one is -1, 0, and the other is 0, -1. So this region right here is the solution, and even on the boundaries right here, all of those points represent the solution for all 3 of these. Okay, pause and see what you can do. And here are the answers. Notice that I went ahead and graphed the line here. Notice it's at 3, down 1, over 1. Y greater or equal to 3, so here's my boundary of y equal to 3. I want above it. And here is x equal to -5. It's a vertical line. I want all values greater than it, and it creates this triangle area. These are the vertices for it. Pause. And here are the answers. I have these 2 equations here that I went ahead and graphed. Y is greater or equal to x minus 2. Here's x minus 2, and I go up 1 over 1, up 1 over 1. Here's my boundary. It's solid. I graph above it. Here I had to solve for y, so here I'm at 2, and I go down 1 over 1. Here's my boundary. I graph underneath. And the last one right here is x is greater or equal to -2, which is a vertical line, x equal to -2, and all values to the right of it. So it creates this triangle area, and those are the vertices. On our last problem, let's take a look at why we look at inequalities. The auditorium seats 800 students, and the drama club wants to make $3,400, and they're going to charge adults $7 and students $4. So the first equation I can see is x plus y is less than or equal to 800. In other words, they can't have more than 800 seats, so it has to be less than. We can't get any more than that. So here's going to be one equation. And the second equation is about money. So we're going to take 7 times the number of adults, 4 times the number of students, and they want to make at least 3,400. That's their goal. So they'll be happy to make more than that, but at least 3,400. So we have a greater or equal to sign. I'm going to solve for y here, and here's one of my equations that I'm going to be able to graph. And when I solve for y on the second one, I'm going to get the -7 over to the other side. And then when I solve for y, I'm going to get -7 over 4x plus 850. I know because of the graph, I'm going to have a hard time graphing 7 over 400. So I changed it to -700 over 400. That's going to reduce to that, but things are by hundreds here, so it's going to be easier for me to graph. Let's take a look at the next slide and how I do that. So here's the first one. Here's at 800, and I go down 200 and I go over 200 because that'll make a -1. And so that red one is the number of people. I cannot get more people into that auditorium. Okay, the green one is going to be actually the money right here. I'm starting at 850, which is right about here, and I'm going to go down 700. 1, 2, let's see, 1, 2, 3, 4, 5, 6, around here, 7, and then I'm going to go over to 400, so it's about right here. And then I'm going to join these two. And then I see I have to do greater, so all of these is greater. So this is the solution region. And the question is, will this number be in the solution region? And here's 200, and I go up to 475. Really is hard to tell, very hard to tell. I don't know where that point is, whether it's outside the region or inside the region. So I took the 200 and 475 and I put it back into the original. Certainly it fits there. And I put the 200 into here and the 475 into here, and I found that it added up to 3,300, which is not our goal of 3,400. So the answer is, could the club meet its goal? And the answer is no. It's close, but it hasn't met the goal.